Hello and welcome back to Gaffy's Grinds. In this video, we are going to be continuing our Back to Basics titration series where we are working our way through some exam questions on titrations. We started with the ordinary level questions and we're going to continue working through these. So this is the ordinary level titration question from 2018. It was question 2. So grab your exam papers now and open them up and follow along on your paper so you can mark the papers out. And also make sure that you grab a calculator and a piece of paper and a periodic table. Okay, so now that you have those, we're ready to begin. What I'm going to ask you to do is I'm going to ask you in your exam papers or on the screen here to pause the video and read this piece of text. Okay, so hopefully you've read that carefully. Now I'm going to ask you to highlight anything on your page that you think is important in that piece of text that we might need later, just so it's highlighted when we come back to it. Okay, good. All right. What would I highlight here? I would highlight 0.5 molar of sodium carbonate. Okay, so that's one of our solutions. Was prepared, and I'm changing the color then used to find the concentration. So we're trying to find the concentration of hydrochloric. So that's going to be our unknown. Some piece of equipment we use, blah, blah, blah. For each titration, 25 centimeters cubed of sodium carbonate, which I highlighted above in green. So I'm going to highlight that again in green. 25 centimeters cubed of the sodium carbonate were used. Were measured in the conical flask, and the table below shows the amount of hydrochloric acid that was added. So this here is our information about how much acid was added. So I'm doing that in blue because I had this in blue up here. All right, moving on, let's answer some of the questions. We can come back to that information later. Part A says name pieces of equipment A, B, and C. So part A, let's name A, B, and C from here, here, and here. That should be very easy for a higher level student. Pausing the video and writing those answers down. Okay, and it should only be playing if you've written an answer for each of those. And let's have a look at what they should be here. So as you can see, part A is up here, volumetric, burette, and pipette. Your marks are 5, 3, and 3. So 5 for the first correct one, 3 for the second, and 3 for the third, which means total of 11 marks. Hopefully we got all those 11. That should be very easy for a higher level student. We're talking about those same pieces of equipment again here. It says which pieces of apparatus A, B, or C was used for first this, then this, then this. So pause the video and read what we were doing in each section, 1, 2, and 3 there. And then we're answering B for part 1. Which piece of equipment did we use, A, B, or C? For part 2 and for part 3. Pause the video and write down your answers on your page now. Okay, and checking those answers off again. For part 1, we used the volumetric flask. For part 2, we used the pipette. And for part 3, we used the burette. 6, 2, and 1, total of 9 marks. So you should have 20 out of the 50 marks got so far. That's all very easy, all very straightforward, I'm hoping. It says here the wash bottle was used to rinse those pieces of equipment A, B, and C, but also the conical flask. So don't forget this one, with the ionized water. So all of these were washed with the ionized water. It's telling you that. It says then identify one of these pieces of apparatus that was rinsed again with a second liquid. So out of these first 4 here, just one of these, write down the name of one of these that was rinsed with a second solution. Pause the video and write that down now. That's part C. Okay, so hopefully we identified that in a titration, we would rinse both of these pieces of equipment, B and C, with the solution that they're going to contain. We do not do that with the volumetric A, and we do not do that with the conical flask. They just get washed with water. So B or C here is the answer. B or C. So either of those is what, 3 marks. Give yourselves 3 marks if you got that right. Good. Next one, the 0.05 molar Na2CO3 solution is a standard solution. And I'm seeing that this is underlined, standard solution. D, explain the underlined term. So what does standard solution mean? So pause in the video and writing down your definition of a standard solution. Again, this is a very common definition in this section, so you should know this. So what is a standard solution? What do we have to have here as part of our answer? A standard solution is a solution who we know the concentration of. So what's in bold here has to be in your sentence. It's a solution whose concentration we know, or with a known concentration. What, 6 marks? Give yourself the marks if you got it right. If not, then you have to unfortunately give yourself a 0, but I'm hoping for a higher level student, that's very straightforward. Indicator, always something about an indicator. E, we've got 9 marks, so this is usually 3 for the name of the indicator and 3 for the color at the start and the color at the end. So here it says name a suitable indicator for this titration. What color change was observed at the end point? Here is the reaction, so you can see the chemicals, HCl and Na2CO3. What is the indicator used here? Pause the video and write that down. Well, of course, if you need a little bit of help here, this is a strong acid and this is a weak base. So that should give you information about this reaction and which indicator is used. So another chance to pause and write down the indicator and the color change. All right, strong acid, weak base, methyl orange, SOBMO. I told you this in previous videos, SOBMO. Strong acid, weak base, methyl orange. All right, so methyl orange is the correct answer. Well done if you got that right. And then for the color change, you have to write the before color and the after color. Methyl orange is yellow in a base, and it's always mixed with the base in the conical flask first, and it's yellow and it turns to red. Okay, so yellow at the start, red at the end. Now, if you weren't sure which one is in the conical flask, well, you can go back up and read the text here. Okay, so it says a solution of sodium carbonate is prepared and then used to find the concentration of hydrochloric acid. Some pieces of blah, blah, blah. For each titration, 25 centimeters cubed of the sodium carbonate were measured into the conical flask. So there you go. Na2CO3 is found in the conical flask. Okay, I'm going to draw a better picture of a conical flask. Okay, so if it's in there, then that's the base, and that means that your methyl orange has to be yellow in there. Okay, the next one then is the calculation. Okay, the calculation. So at this stage, I'm going to ask you to pause the video, read through this piece of text again. Okay, and you may need to scroll back up and see the numbers again if you want to make a note of those numbers. Okay, so this is the amount of acid that was used in the 3 titrations. You should know that we don't use all of these figures. Which ones do we use? And then what one do we put into our titration value? Okay, and hopefully now you guys can go ahead and find the concentration in moles per liter. So the concentration, calculate the concentration in moles per liter of the HCl solution. So pause in the video and doing that now, please. All right, the answer that you should have got here was 0.11 moles per liter. 0.11 moles per liter of HCl. So well done. If you got that, then you know you did it right. If you didn't get that, then we're going to try and help you through this. Okay, so if you didn't get that right, stay tuned and we're going to step you through it and get you to have another go at it. Right, the first thing I always say is for my students to write down the 2 reactants. HCl is 2HCl plus Na2CO3. Now you could write down the rest of the equation here, but it's not really relevant. We're only interested in these 2 things. All right, the next thing I always ask my students to do is use 2 arrows under each of these substances and write down the concentration of each in moles per liter and the volume used per titration in liters. All right, so first of all, we know that the Na2CO3 is 0.05 molar. In the ordinary levels, it makes that very clear what the concentration is, 0.05 m. And then we use 25 cm cube portions of that. So that's the volume here, but I need that in liters. So pause the video and convert this to liters right here, right now. Okay, so hopefully you got 0.025 liters. Good. The HCl is a little bit more complicated. First of all, we know we're trying to calculate the concentration, so we're not going to know its concentration, question mark molar. And then the next question is how much did we use? Okay, well, of course, these were our titration values. Now, what you guys should know is we always scrap the first value, the rough titration. We don't include that. And then we do an average of the accurate one. So we got 22.7 and 22.6. So a little bit of rough work here. We're going to get an average 22.6 plus 22.7. We want to divide both of them by 2 to get the average value. So pause the video and do that now. And of course, the answer you should get on your calculator here is 22.65, and that's centimeters cubed. Now, I need that volume in liters to put here. So if you didn't already do this, convert that to liters for me now. Pause the video and do that. Okay, so what you should have got here is 0.02265 liters. All right, now now that we've got this far, that's the hard bit really done. The next thing is to work your way through to find this concentration. Start with what you know and work towards what you don't know. Okay, so plan out the steps. What are we doing? Okay, so pause the video and have a go at this now, please. All right, so first of all, we're starting with what we know, which is moles of Na2CO3 per liter. And you want to convert that to just how many moles of Na2CO3 we use per titration. Because we don't use a full liter in a titration, we use a different volume, much smaller volume. Once we figure that out, then we want to find out how many moles of moles of HCl that reacted with. And then we want to find the concentration of that, say, HCl, so moles per liter of the HCl. So that's the plan. Again, if you weren't able to do that, now that we've showed you what you need to do, let's work our way through it. Pause the video and do that now. Okay, so a reminder, the first thing we need to do is get rid of liters. How would we do that? We've got to convert this to just moles. Again, a chance to pause the video and work your way through. All right, so let's do this together. We got 0.05 moles of Na2CO3 per liter. That's what we know. That's what this here tells us, 0.05 moles per liter. And we know we want liters to cancel. So therefore, I've got to multiply by a number of liters. Multiply by a number of liters. Okay, so that I can cancel. Like that. Now, how many liters did I use? Well, it was this number here, 0.025. So I'm going to times this by 0.025 to tell me how many moles I use in a titration. So once you do this, go ahead and do this now. Get ahead of me. Okay, so should only be playing if you have an answer in moles here. So I'm getting 1.25 by 10 to the minus 3, and that's moles of Na2CO3. So now we're up as far as here. Now we want to get from moles of Na2CO3 to moles of HCl. So I'm going to do that on the next line. So I'm just rewriting out the moles of Na2CO3 on the next line. 1.25 times 10 to the minus 3 moles of Na2CO3. And a reminder, don't drop the units, guys. If you drop the units, you're going to get lost. You're going to get confused. Now, of course, to go to moles of HCl, I need this to cancel. So I'm going to multiply by a conversion factor that has that in the denominator, moles of Na2CO3, like that. And then I can cancel those two. And I need moles of HCl in my answer. So they're going to be on the top here, moles of HCl. Okay, go into my balanced equation to find out what the relationship is. I have 2 moles of HCl for every 1 mole of Na2CO3. So when I get my answer here, it should be in moles of HCl. And of course, that's going to give me 2.5 times 10 to the minus 3. And that's moles of HCl. All right, so I am now up as far as here. And I want to find out how many moles per liter did I have. This was the amount of moles in one titration. Well, what volume was that in? So I'm going to take this moles per liter and find out what volume that was in. So put liters on the bottom. And of course, here is the volume that my moles of that many moles of HCl were in. So this was in 0.02265 liters. So put that over 0.02265, and that will give me an answer of 0.11 m molar HCl. All right, guys, that's that question done. For a higher level student, I expect that to be seeming to be getting pretty easy now, okay? But still, we're going to stick with them and do a few more before we're ready to jump into the higher level ones, because they definitely do get harder. Mostly because the wording is a little bit harder. They hide things on you. They change the wording, make it slightly more difficult to read. And then there's usually a little extra bit at the end of finding the molarity of the unknown solution. But that is the start of the titration. The start of most calculations is the same. You're finding the molarity of the unknown. And that gets you most of the marks, even on a higher level question. So it's really good practice to be doing this. All right, guys, that's it. I shall see you in the next video.